Now let's take a look at finding the equation of the parabola in problem 4c. First, let's look at the domain and range. The domain of a function is all possible x values. A better definition would of course be all possible inputs, but for right now we're just going to leave it as all possible x values, and the range is all possible y values. Once again, a better way to say that could be all possible outputs, but this definition will suffice for now. Now, if in this parabola there are no x values that would not work, this is true of all parabolas, there are no x values that we cannot put in, so the domain is all x values. You could also say all real numbers, or write this symbol right here, which is how mathematicians like to write all real numbers, and I quite like it. This is a very shorthand way to say all x values or all real numbers. Now the range is a little bit more complicated. So the range, if we look down here, there is a minimum value to this parabola right here. So there are some y values which are not possible. For example, y could never equal -7. We could never go down here. Now this doesn't cross exactly somewhere perfectly, like right here for example, but we can still estimate. So we're going to say this is about -1.5 and about -6.2. If you are going to say something a little bit different, like -6.3, -6.1, that's totally fine. We're going to say that y is greater than or equal to -6.2, because this is saying y is always going to be greater than this value or equal to it. So we could also write it like this if you're writing on a computer and you can't make the greater than or equal to sign, and this would be the range. Now let's look at how to actually find this equation. So last time we found this using the vertex method. However, the vertex of this parabola is kind of unclear. It's hard for us to say exactly what it is. Fortunately, the roots are very obvious. We have a root at 1, 0, and we have a root at -4, 0. So because the vertex is not clearly identifiable, but the roots are, we're going to use the intercept form. Now the intercept form is y equals a times x minus p times x minus q, and p0 and q0 are roots. So this is a really good method to use when we are dealing with the roots of a function. Now, right here we have the point 1, 0, so if p0 is one of the roots, we could say p is equal to 1, and if -4, 0 is another root, then we could say q is equal to -4. It could be the other way around. I'm just choosing it to do it like this. Plug these into the equation, we'll get y is equal to a times x minus 1 times x minus -4, which will simplify to y equals a times x minus 1 times x plus 4, because subtracting a negative is adding a positive. Now all that's left is to find a. This has to do with the vertical strength and stretch, so when you go over one, you go up one. However, personally, I think that's kind of hard to identify right here because it doesn't exactly match up with our grids. So I'm going to do this algebraically, but you could also say it's probably just going to be 1, but I want to do it exactly correct. So we're going to take another point that's easy to use. Usually vertical or y-intercepts are really easy to put into equations. So this point is 0, -4. And I'm going to substitute that into here. So that says when y is -4, x is 0. So I can just plug it in like that. And I'll get -4 equals a times -1 times 4. So I have -4 equals a times -1 times 4, which becomes -4 equals -4 times a. Multiplying both sides by the reciprocal of -4, which is -1/4, will make it so -4 times -1/4 is equal to 1. And then same thing over here, this will be 1. So that tells me a is 1, and our equation is y equals x minus 1 times x plus 4. Okay, all that's left is to convert our equation in intercept form. This is the equation in intercept form into standard form, because that is our ultimate goal. To do that, all that's left to do is to distribute. So I'm going to multiply x with x, which is x squared, and then x with 4, which is plus 4x, and then negative 1 with x, which is minus x, and then minus 1 with 4, which is minus 4. Combining like terms gives me y equals x squared plus 3x minus 4. And that is my equation in standard form. So remember, when the roots are identifiable, but the vertex is not, you want to use intercept form. Finally, let's take a look at the parabola in problem 3D. First of all, let's look at the domain. Once again, parabolas always have a domain of all real numbers. This is just saying all x values, but I like to write that because it's quicker and looks cool and is what math people do. And then the range, this parabola has a minimum value at approximately negative 6.2. So this range is just an estimate, but that's totally fine to do. So our range would be y is greater than or equal to negative 6.2. If you say something slightly different than that because it's an estimate, that's totally fine. Once again, remember that you can always write it like this on a computer, and I will know exactly what you mean, and this means greater than or equal to 2. You could do this to write less than or equal to as well. So if it was going this way, you would write y is less than or equal to negative 6.2. Just write something with an equal sign and a less than or greater than sign, and I'll know what you mean. Okay, now it's time to find the equation again. Once again, our first step is to identify whether this parabola is easier to find the equation of in vertex or intercept form. If it was good to find in vertex form, the vertex would be clearly identifiable, and this one's really hard to see because it doesn't line up with our coordinate grid very well. I'm always going to give you one where either the vertex lines up well or the roots. In this case, the roots line up really well, which tells me intercept form is probably the best. Once again, intercept form is y equals a times x minus p times x minus q, where p0 and q0 are roots. Okay, so our roots is this point here, which is 2, 0, and this point here, which is negative 3, 0. So this would tell me, if I'm just going to match these up with p and q, then we're going to say 2, 0 is one of these, it's going to correspond here. It could be here, but let's just leave it like that. So this will give me p equals 2. And then let's also match this one right here, which will tell me q is equal to negative 3. Now let's plug that into my equation, and I'll get y is equal to a times x minus 2 times x minus negative 3. X minus negative 3 is plus, so this will be y equals a times x minus 2 times x plus 3. Now we just need to find a. You could look at this geometrically and see that when you go over 1, you go up 1, but it's kind of hard to tell that precisely since it doesn't go through the coordinate grids. So let's just pick another point. So I'm going to pick this point here, which is 1, negative 4. So I'm going to say when y is negative 4, x is 1, so I plug in this for y and this for 1. Negative 4 equals a times 1 minus 2 times 1 plus 3. Negative 4 equals a times negative 1 times 4. So negative 4 equals a times negative 4. I could take the reciprocal of negative 4 multiplied to both sides, or I could just think, well, if a times negative 4 is 4, then the only number that a could possibly be is 1, so a is just 1. So then I'm going to write y equals 1 times, you don't have to have this 1 here, but I'm just including it because we found a is 1, x minus 2 times x plus 3. This is not in standard form, so we need to write it in standard form. So I'm going to FOIL. Really, it's just distributing, but it's a good acronym for now. So we're going to write y equals x squared plus 3x minus 2x minus 6. And I did the combined like terms to get y equals x squared plus x minus 6. And that is my equation in standard form. And we are all done. Remember to leave a comment on one of the videos with any questions, something you thought that was interesting, or just general thoughts. It's a good way for me to know where everyone is at on the concepts.